Hello everyone, in this video we want to design a geodesic grid shell. If you just search for geodesic grid shell, you will see that a strip or the profile of the material is aligned to the surface direction. So how to design them? To start, we need to have a surface. This surface can be either designed inside Rhino or Grasshopper using different methods, or we can use the prepared surfaces, for example using the Lunchbox plugin. So I will open the Lunchbox plugin tabs to see what kind of surfaces we could have. So in the mass section you can see all the different type of surfaces this plugin provides. For example, you can have a torus surface like what you see here, or also we can have a hyperbolic surface that we use now. And as you see, there are some information or inputs that you can change them to have different kind of surfaces. For example, these last two inputs is the domains. So I will use one construct domain component and check what is now. It's -4 to 4. So let's say if we just reduce it to half, so for example having it from -2 to 2, how it can be different. So if now I connect this output to the domain 1, you can see that this is different in this way, and if I also connect it to the D2, you can see that the whole surface is now slightly changed. So if I change this number, you can see how different it can be. Okay, let's say this number 2 would work for us. And now this is the surface that we want to start to apply the geodesic pattern on it. And how we can do that is to extract the edges of this surface and then connecting these points together. So basically the meaning of geodesic, which you can just type it, or you can also find it inside the curve tab here in Spline tab. What it shows, you can also see the information about this component, which says that it constructs a surface geodesic between 2 points, which means that it's the shortest possible path on this surface to connect 2 points. To just start looking how it works, we should see what are the inputs. It asks for a surface as an input, for example this surface, and 2 points, the start and end points. To extract them, we can just deconstruct it from this surface. So I'm going to use the explode component to extract the curve output and extract the segments and the vertices of it. So for a start, let's just consider these 2 vertices. I want to connect them together on this surface to see how it can be. So if I extract it using the list item, you can see that this is the first point, which I don't want it, I want this 2. So let's say number 1, index number 1, which will be this point, and the other one I will connect the item number 3. So if I connect these 2 as the start and end point, you can see that this line is drawn on top of this surface. So just to remind you that how it's different from the line, so the line would just connect these 2 points together without considering any surface. In some cases it can be both the same line if the surface on that specific location is planar or is without any curvature. So for example here you can see that this happened. But if we consider, for example, these 2 different points, you can see it's different, or even these last points. So for example, index number 3 with index number 2, or index number 0 with index number 1. So you can see that This is the geodesic on this surface, and this is the line which is not on top of the surface. It's not aligned with the curvature of the surface. So it's very important to know the difference of these two curves. So for now we don't work with line anymore, we only consider the geodesics. So now we understood how this path would work between different points of the surface. And now I can just extend my endpoints not only be on the vertices of this surface, but be on the whole segment or edge of the surface. So for doing that, I'm going to extract the segments, again using a list item. And so I can say this is segment number 1, and for now I want the other segment to be number 2. So I will extract this one as well. And to have some points on it, I can use this evaluate curve to extract one point only on this specific curve, and it needs a t-value, so it's always between 0 to 1. So I will write 0 to 1, and then I can reparameterize this curve to make it easier. Otherwise this t-value should be in the range of these lengths, which is hard to do. So just to make it easier, I put it on 0 to 1 and change the domain of the curve into or reparameterize it from 0 to 1. So now I can have this point 0, which means the start of this curve, or somewhere between, and 1 is the end point. Okay, I would say this is the start point for me, and I want to have a geodesic starting from this point, and the end point I also do the same for the second curve, which is this index number 2. And let's just change its position, for example somewhere here, and I consider these 2 points as the start and end points. And you can see that you can change the position of these points, and now you can see that how this geodesic curve would have different paths between these 2 points. Okay, now if we want to have a grid, we need to have also a grid of points or a list or array of points. To do that, instead of using evaluate curve, we are going to use divide curve. So we divide our curve into specific lengths or distance between them, and we can define how many we want. For example, in here we set number 10, so let's change it to something like 6. And I will do also the same for the other direction or the other curve here. And now if we connect both of them together, you would see that the first point from this curve would connect to the first point of the other curve, which is here, because the direction of these 2 curves do not match. To solve this, we need to either flip this curve from beginning or just do a reverse of the points, which means we change sequence. So if we just do this reverse, it's easier, and you can see that now the numbering of these 2 lists works. Just to show you another time, you can just also write point list to just see the indexes of these points. And I will change the size just to see it more clear. So you can see that this is 0, 1, 2, 3, 2, 6, and we have it also here, that now it's arranged in a right way. So if we again remove this reverse, you can see that the list starts from here, from 0 to 6. Okay, so now we can also have the grid in the other direction, so perpendicular to these ones. to this direction. And for that we need the other two list items. So I can either just copy this part, maybe it's easier, or only this part. I can copy, and I will consider number 1 and number 3. So this edge and this edge, and everything is the same because I want the same set of numbers, and also the two lists to be in the same sequence. So that's by reversing one of the list of the points. And I just copy this part also. And for here I can use this double click and make one of these suppliers, which is just connecting all the curves together and just making the code look a bit less complicated. So I can also use it here because all of them are connected to this wire of a segment. So I'm going to connect all of them here, and only this one is connected to the segment. Okay, and now we have this surface and these two set of geodesic curves. So we have both the directions, U and V directions, and our grid in a linear way is ready. Now if we want to make it look more real, we need to make these surfaces, or the last of the profiles. We can either move it into two directions and loft them together, or make it more precise. First we want to do the first or the easier method, which is just by moving these lines into two directions on the surface and then loft it together. To do that, we just write offset, and we can also use offset on surface. So I connect these curves, and I would say what is the distance that I want to have as a offset. For example, I would say 0.5. We can change it later. And what is the surface, which I would say this surface. So this is the offset in one direction. I can say that's enough, or I would consider this curve as the middle one and do the offset into both directions. That can be also a method. And for doing that, I'm going to copy this component and add one minus the distance, so that I have it also in the other direction. So now I have these two curves and I will loft them together. So the good thing about using this offset on surface is that these two curves are already located on the surface and they are not somewhere in the space. So I loft them together. As you see, we have it here. So to make it more clear, let's use this custom preview to hide the surface and only see the boundaries. I'm going to use a swatch and make it transparent. Yeah, like this. And what else we don't need to see anymore? For example, these curves, because we now see the surfaces. You can also increase this transparency more. And I will make a copy of this part and apply it also on the other direction of the profiles. So I just copy it here and connect the C to the geodesics. and here you see the whole grid is formed. So now I can also hide all these parts, maybe also hide the surface, just to see how this grid looks like. I can also give it a color just to make it different into two directions. For example, let's say this direction I will consider a red color, and I will copy this custom preview and we'll make it, let's say, blue or the other direction. Okay, so now we have this grid of the geodesic pattern. This pattern can be different by changing this part in here. How these points are connected together would change everything. Now we can do some changes to see how different this pattern can be. For example, if instead of connecting edge 1 with edge 2, we would say edge 0 to edge 1. So you can see that now these two are connected together. And I can keep this part as it is, or also change it to make it from number 1 to number 2. You can see this is also making it different. Now maybe we can also add this part of this pattern, which is connecting edge number 3 to edge number 0 and edge number 3 to edge number 2. So let's also add this part. So it's everything just copying. What's the problem here? Let's check. So here it says that one of the offsets is failed. And what is the reason? We can check in here. How many curves we have? 7 curves. Okay, the reason is that the last curve is somewhere here, but it's already not a curve because it's connecting two exact points together. So if we just extract the last curve, which is by taking a list item and using a reverse. So the last curve, we don't see it even. And if we check it with the length component, we can see that the length is 0, which means this curve does not exist. So this red color is the reason of that one, because the last point of these two would match to the same location and there is no curve. So just to know it, and how we can solve it is to just eliminate this last curve, and that's by using a call index. And I'm going to connect this output of Geodesic to this call index and would say 0, index 0, and if I do a reverse, means that the last curve, because I see it here also that the last one has a problem. So I connect this output instead of this. So that's by Control and Shift. If I connect it, all the things that was connected here will connect to the next part that I want. So that's how it works. And now you can see that this problem is solved here. If I do the same here, the problem would be also solved for this set of curves. So I move them a bit and I will use this output here. Okay. This is only to solve this problem of here, and now we can extend this pattern to these two directions, and that's by having, as I told you, 0 to 3 and 3 to 2. So these two edges should also follow the same rule of here. I will just make a copy of all these parts twice. So the first part I will use it. Okay. Now the code is becoming messy. Just let's change some positions so that it's more readable. Okay, here we have these surfaces. Maybe I'll also bring all here. I have an extension of it here. Okay. And then I can sort all of them in one arrangement. Also these ones. Okay, I just skipped this part because it was just to check how it looks, the whole code. And now coming back to this part, so we change here from 0 to 3, and here from 2 to 3. So we need to change this number to 2. And here to 3. So what else we need to do? We need to also change these colors if we want, or we keep all of them as one color. So let's change the whole colors to one plywood-like color, something like this. Okay, so now I can hide all the other parts of the code, and this is how this pattern would look like. If we unroll these surfaces or these profiles that we have in here, just let's check how they are located. Because what geodesic flexible geodesic gridshells, or also called elastic gridshells, would look like is that they can be unrolled into a one flat surface. So if we check, we can see for here. So for this set of surfaces here, we have this unrolled versions, and let's bake them to, for example, layer 3, just to check if they are linear and straight or not. You can see that they have almost a good precision to being unrolled into a one straight flat surface. But let's see how many did we have and how many we have in here. So in here we had 1, 2, 3, 4, 5, 6. So the number is not enough. And what error we get here? It says that could not be unrolled. So there are some surfaces that could not be unrolled, and this has to be solved. So let's check with the second method to see if that solves this problem or not. So let's hide everything we had in here. We only now need this surface, which I will bring again. And now we want to use the second method. So in this method, again, we have this explode as we have it here, and Now instead of offsetting this curve, we want to use the same curves and then loft them together. And how we can do it? Again, we go to the list item of this segment. So some parts of it would be repetition, so I just skip these parts and make it fast forward. We can increase the number of these points, so let's say 20, and there's a reason for this. So I just make a copy also for here. And now instead of using all these points, I'm going to select only some of them. So for this I will type this patch, and I would say this set of points, and then I select which points of this I want to keep. There is a pattern for it here. It's written true and false. If I right click on this pattern, I can change it using this set multiple booleans. And let's just check how it works. So if I copy this true, what would happen? I can also hide this part to only see the output. And it has two outputs of A and B. So if I connect points to only the A and I hide it, you can see that what this true and false did, it means that it kept the 2 points because we had true, true, and false, and then the second point, which was false, is deleted from the list. So it went to list B. Now what we want to do is to use this list B and just have these points and the point beside it, and then draw these geodesic lines in these parts. So for solving this, I'm going to go here and change it to false, false. Now we can see that we have these 2 points, so I will draw 2 curves here and also here. So just copying the same thing for the other path, and again reversing the outputs. Now if we type geodesic, again we have this start and end points, and this is the surface. Okay, so we have the curves created, and now if we loft them together, what happens is that it's lofting everything together. But what we need to do is first to make a partition, to make each 2 together should be lofted. So I will change here to number 2 and connect it to the output of connect it to the input of these curves. Now if we hide everything, also the surface, you can see these curves. Now if we check with unrolling the surface, so this time we don't have a problem for here. Now let's change it again to between 0 and 1. Let's see if we have the same problem or not. So we don't have it here. It means that this method is more precise. So what I will do is just to make it again fast forward and do this process similar to the process here. So have it between 0 to 1, 1 to 2, 0 to 3, and 2 to 3. So if we want to see them more clearly and not on top of each other, instead of this having one empty plane, we can define some points. For example, we say construct point, and we make a series of points in the x direction, just as an example. And it's important to also flatten this part to see each of them separately. So if I also add one value for y, for example number 12, so now you can see that these are all these strips, and the numbers should match. So how many we have in here? It's 20, so this count should also change to 20. And now you can see that these are all these strips that we have. So this is how to make this pattern of the geodesic strips and make a grid out of it. For sure you can change all these setups and change how these curves are connected to each other and make different variations. These were just examples of how you can do it. I hope you enjoyed this video, and see you in the next videos. Thank you.